Hey calculus kids, this is Dr. Callahan with week 2 Thursday. How are you guys doing? Welcome to semester 2 of calculus. Go ahead and pause the video and answer the following questions for your warm-up log. All right, I'm going to go ahead and create the assignment for this class. Yesterday, keep in mind that you guys had your AP College Board assessment on definite integrals and also Riemann sum for week 2 Wednesday. On AP College Board, it is 8 questions multiple choice. And also you have your Math Excel, which is ongoing for week 2. It is due on Sunday. For those of you guys who emailed me about the time difference, thank you so much for that. I went ahead and modified it and it has been changed. So today we're going to do 2 different things. The first one is we are going to find the area of geometric shapes. And the second thing we're going to talk about is a continuation of definite integrals. Your instructions for today is simply to watch the video, do the activities that's described in the video. It should be equal to 45 minutes of instruction. The video can be accessed from MS Team or from the YouTube channel. And then of course your Google Doc for calculus is also here that has your syllabus and other information such as the AP exam in addition to your Wednesday's assessment correction templates. Hard copies are also available to be picked up outside of my classroom. Your class is for second period. You should be checking in to meet with me on MS Team at 9:20 to 10:05 on a daily basis. And I'll go ahead and assign this then. So today there are several things that you need. We have several pages of notes that we will be using. If you have a printer at home and you would like to print this out, I'm going to go ahead and save this on a separate guided note so that way you guys can print it out at home rather than printing out the entire document for the first 9 weeks. And again, the hard copies are outside of my classroom as well, so you will be able to find that and get a copy for the first 9 weeks of school. Let's go ahead and save this on the PDF for your class. Week 2 Thursday. And we'll do that as a PDF. Okay, so then let's go ahead and attach this to your assignment for today. So here's the assignment, week 2 Thursday. I'll just go ahead and attach it from my computer. And there you go. All right, so if you click on this, this is what your guided notes look like today. There are about maybe 6 or 7 pages there. and it's loading, or 8 pages, excuse me. So here are my notes on the Riemann sum and definite integrals. There are several examples here. Actually, 3 different examples. Also, we're going to talk about areas of common geometric figures, which looks like this. I also have a little review of the summation formula, which we're going to continue on, with some additional examples of summation, Riemann sum, and how this actually works, along with some textbook practice, and then of course your guided notes right here on the fundamental theorem of calculus, which is for the antiderivative integral properties. This is our notes today. We're going to have 5 different examples, and that is the breakdown we're going to be talking about. So with that said, let's go ahead and get started and jump right in. Your answer for the warm-up looks like this. And what I have here is your guided notes with your breakdown of everything. So we're going to have 2 different parts. Part 1, finding the area of the geometric shape using 2 different methods, graph and integration. Part 2, notes and definite integrals. Part 3, using 2 different questions on summation formulas and Riemann sum. All right, so with that said, let's go ahead and get started. So turn over to this part of your notes, please, on the common areas of geometric figures. So first we're going to do is going to find the area with graphs, graphically. And then we're going to go ahead and find the area with integration. So we're going to kind of transfer from using a graph to find the areas like we have been doing with the Riemann sum with like a bunch of rectangles over with the areas of integration. All right, so let's take a look at the first part. For an integral of just 4, what it's talking about is it's asking you that if you were to go ahead and draw a line that is y equals 4, which will look something like this. You go up, you draw your straight line, okay? And if you look at the interval, it's between 1 to 3. So here's 1, 2, and 3. It's this rectangle right here. If I were to find the area of this rectangle, I will find the base times height. And if you look at the base, in between 3 to 1, you subtract 3 minus 1, which gives me a base of 2. And then height, well, given the fact that my horizontal line is at 4, my height is 4. So finding the area between 1 to 3 of this rectangle, or this area underneath this graph, between 1 to 3, is just going to be 2 times 4, which is going to be 8. Let's take a look at the second one. Second one, you have x plus 2. So if we were to find the area of this, if you look at this right here, I'm going to start at 2. And then remember, your slope is a 1 over 1, so you go up 1 over 1, up 1 over 1, up 1 over 1, and I draw my straight line. Now, you're not finding the area of this entire region underneath the curve. You're only going to find the area between 0 to 3. So then here's 0, 1, 2, 3. Draw your lines here, and it looks like this weird shaped trapezoid, doesn't it? So there are 2 different ways of you can finding the area of this. The first way is that you can go ahead and just use the trapezoid formula. And the second way is you can go ahead and break this down in the form of a rectangle area plus the area of a triangle. But since we've been talking about Riemann sum, we can just go ahead and look at it as finding the area of a trapezoid. So then my base 1 is 2. Base 2 is going to be, here is 2, and then 3, 4, 5, so 5. And then my height for my trapezoid is from 0, 1, 2, 3. So then if I were to find the area of this, it's going to be 1/2 base 1 plus base 2 times height. So then I have 3 over 2 times 7, which is 21 over 2. And that's my area. Then let's take a look at the third shape. So anything with a square root, remember, is always going to give you that weird little curve shape. But with this square root, it's a 4 minus x squared. So what that means is that when I draw my half circle or semicircle, and if you're not sure what shape it is, you can go ahead and graph this on your graphing calculator. Square root of 4 is going to be a 2. And because it's a minus x squared, you know it's going to be a sad face. So with this one, I'm going to start off over at 2 to the right, 2 to the left, draw my semicircle like so. My diameter here is going to be 4, but I know that my radius is 2. So then if I were to find the circle, okay, so give me a second, and I just close down. Sorry about that, guys. It seems like the computer didn't like what we're doing and it just shut it down. So let me open that again. All right, so then here we go. So then when we find the area of this, remember your area is going to be 1/2 pi r squared, because it's 1/2 since it is a semicircle, so half of a circle. So my radius is 2, so then 1/2 pi times 2 times 2, which is 4. 4 divided by 2 is just 2 pi, and that is your area of this semicircle. All right, so then this is your answer. So that's how we go about finding the area of this using a graph. Today we're going to talk about how to do this with definite integrals and using antiderivatives to do this. All right, let's go ahead and get started with your guided notes right here on this page. First thing I want you to do is go ahead and read the part that's highlighted in yellow. All right, let's go ahead and take a look at this then. Example 1. If I were to go ahead and do this by finding the area under the curve graph-wise, I would have the graph 3x squared plus 4x minus 1 on my graphing calculator. And that's a polynomial. It's going to be 3x squared, so it's going to be in the shape of a parabola. And then I'm going to go ahead and just use the notation of 1 to 4. So those are the intervals that I would find. So like, for example, if this was my graph, and I'm going to go ahead and see what shape it's going to be. So 3x squared plus 4x minus 1. The shape of the graph is going to be indeed a parabola. It's going to be a happy face parabola, looks something like this, because it's a positive 3x squared. And because it's from 1 to 4, you're going to look at 1, 2, 3, 4. Oops. There we go. So the area that you're going to be looking for is just this area between 1, there's 1, to 4. And the area that you're going to be looking at is just simply this red area here. So you could go ahead and find the area of that with shapes, but unfortunately with the picture of how this looks, it's just really difficult to use like rectangles and trapezoids to find the area of this weird curved shape. So in this situation, definite integrals will probably be the way to go. So then what I would recommend doing is using your antiderivative. So you're going to go ahead and find the integral of 3x squared plus 4x minus 1. So 2 plus 1 is a 3, so I'm going to divide it by 3. So then that's going to be an x to the third power. 1 plus 1 is a 2, divided by 2. Plus 4 divided by 2 is just 2x squared. Oops, let's try that. And then, of course, negative 1, the integral of that is just negative 1x. And we're going to evaluate this between 1 and 4. And just on a side note, remember if you have the integral of a to b, and let's find the integral of f prime of x dx. To put this back into f of x, remember b always comes first, which is the upper bound. So f of b minus f of a, and f of a is a lower bound. So b is the upper bound, a is a lower bound. And the reason why you want to do that is because if you look at the picture of this diagram that we drew, it's always going to be 4 minus a 1 because the area of 4 is the area of this entire region from left to right, okay? And the area of 1 is, again, everything from left to right, so left to the 1. So this yellow region right there. So if I take the orange region minus yellow region, what is that going to give me? It's going to give you this blue region, which is exactly what you're trying to find between 4 to 1 or 1 to 4. So that's why it's always the bigger upper bound minus the lower bound. All right, so then let's go ahead and do this then. You might want to graph this polynomial into your TI-84, and then you want to do a second calc option with x equals 4, and you're going to go ahead and hit enter. And then, of course, x equals 1, and you're going to hit enter to go ahead and calculate this. You could do this just systematically by plugging numbers in, but if you're on the AP Calculus test, sometimes that does create errors because just of, simple little sign issues. So for the purpose of this, let's just plug this in. So upper bound is 4 cubed plus 2 times 4 squared minus 1 times 4. So what this is going to happen is I'm going to take that minus, when I plug in the lower bound, which is 1, so I'm going to have 1 cubed plus 2 times 1 squared minus 1 times 1. Grab your calculator, work your magic. Your upper bound is going to give you a number of 92. And then, of course, your lower bound is going to give you a number of 2. So my area underneath the curve between 1 to 4, 1 to 4 is 90 units cubed. And that is your answer. All right, let's go ahead and take a look at number 2. For number 2, it's just the integral of -2 to 1 of 2x. So this is a 1 plus 1, which is a 2. So my integral is going to just be x squared. And that's it. And we're going to evaluate this from -2 to 1. So when I go ahead and plug in the upper bound, I have 1 squared minus, plug in the lower bound, -2 squared, which is just going to give me 1. -2 times -2 is a 4, but don't forget the minus sign because a lot of people will do that. And that's going to give me a -3 unit squared. And if you were to go ahead and draw this and see how do you go about getting a -3, well, you can go ahead and graphically draw this. So let's go ahead and take a look at this. To graph y equals 2x, I start at 0. My slope is a 2 over 1, so I go up 2 over 1, up 2 over 1, and this is what I have, and then I draw my line. Okay. And then from there, when I draw the line, I'm going to evaluate this from -2 to 1. So here is -2, and here is 1. And so the region that I found my answer is going to be this green region right here, and this tiny little triangle right there. And I know you're thinking, well, how is it possible that we have a -3 for the answer? Well, if you take a look at this region here, it's below the x-axis. And if it's below the x-axis, it is a negative area. And this area here is above the x-axis. So that's going to be a positive region. So the area above the x-axis actually is just the 1 right here. So that's the above. And then, of course, the -4 is the below. So if I were to break this apart, this triangle right here is a -4. Okay, it keeps disappearing for some reason. So let's maybe use a different pen. Okay, so this is going to be a -4, and this area here is a +1. All right, let's move on. Okay, so now what I want you guys to do is go ahead and read the integral properties right here. So for number 2, notice that it's always between a to b. However, if you go ahead and flip the interval from b to a, like this way, then what ends up happening is that you'll have a negative area, because essentially what you're doing is you have a, let's say a diagram that looks like this, that's above. If I were to flip it down over here, so it's from B to A, then it will be in the negative region. So just keep that in mind. You're able to go ahead and flip-flop this, and we will do that sometimes, but you have to make sure that your answer remains a negative. Now for number 3, this is another good one, because if I have 2 different intervals from A to B, and let's say that there is an interval that is in between them, and I'm just going to call it C, it is possible for you to split the area. So you find the interval from A to C, and then continue it on between C to B. And that's assuming that C is between A and B, although I don't particularly like using C because C really isn't between A to B. A better way of saying this is if it's from A to C, and you can break it from the intervals of A to B plus the integral from B to C, but that's not how the textbook is written. So just keep in mind, C has to be between A and B. All right, let's go ahead and take a look at example 3. I'm gonna have you guys go ahead and practice it on your own. The answers are given to you. So take a moment, pause the video, and answer the following questions. All right, let's go ahead and take a look at A here. So for A, you're looking at, it's saying example 3, if from 0 to 3, f of x dx equals 4, and from 3 to 6, f of x dx equals -1, then find the ones below. Well, for this one, if it's from 0 to 6, I can certainly break this down from 0 to 3, f of x dx, plus integral from 3 to 6, f of x dx, which is the third rule. Now, you know from 0 to 3, you're going to get a 4. And from 3 to 6, it's given to you that it's a 1. So you just need to be careful because you're going to go ahead and subtract the 2. I'm sorry, you're not going to subtract the 2. Just kidding. You're going to add the 2. Yep, so 4 minus 1 is going to give me a 3. And that is my answer. Okay, so for B, if you look at this, it is going from 6 to 3. So it looked like it pretty much flipped because originally your upper bound is supposed to be on top, and then you move that upper bound down to the bottom. So if I were to go ahead and flip this, so I have a 3 to 6 like this, I do need to integrate that negative in front of it, f of x dx, which is just going to be from 3 to 6, gives you a -1, but don't forget your extra negative, which is going to give you a +1. For C, if the integration is exactly the same, it is going by the first rule where it's just A to A. And so in which case it is just going to be 0 because you don't have any area that you're specifically looking at. If you're plugging in the upper bound of 3 and let's say it gave you a number 6, for example, well, guess what? Your upper bound is the same thing as your lower bound. So when you plug in a 3, again, it's going to give you another 6. So when you subtract it, it's going to give you a 0. All right, then for D, this one's a little bit weird because you have a -5 right there, but that's okay because you can actually just move that constant out. So I'm going to move that -5 on the outside of this. Do my integral from 3 to 6 f of x dx plus, and don't forget your 3 right here. So I'm going to put my 3 integral dx from 3 to 6. Well, you know that the integral of 3 to 6 f of x for this first piece right here is going to give you a -1 because you did that piece for b, and that was I'm sorry, hold on a second. Just kidding, not for this piece. You did that for here. It's given to you right here. Sorry about that. So for this side right here, from 3 to 6 f of x dx, that is going to give you a -1. So I'm going to put a -1 right there. Don't forget your -5, so I'm going to put the -5 right there. Multiply together, you get a +5. And then, of course, you have your second piece of this, which is the integral of dx. Well, the integral of 1 dx is just going to be x. So then you have a 3 in front of it. So that's going to be 3x. And you're going to evaluate this from 3 to 6. If I plug in the 6, 3 times 6 is 18. If I plug in a 3, 3 times 3 is a 9, which is going to give me a 9. So 5 plus 9, which is going to give you a 14. And that is your answer. All right, let's go ahead and take a look at example 4. Go ahead and read it. Okay, so it gives you that f of x is f prime of x dx. So f of a just equal to 6, and then find f of 3. So that's my goal. All right, so then if integral of 3 to 5 f prime of x dx equals 10, then I'm going to write this as 3 to 8 f prime of x dx equals, and here it's giving you the equation. It says f of b, and remember your b is 8, minus f of a, your a is 3. So f prime of x dx equals f of b, so that's f of 8 minus f of a, so that's f of 3. Equals 10. In the equation, it's given to you that f of a equals 6. So I'm going to replace that with 6 minus f of 3 equals 10. Our goal is to go ahead and find f of 3. So I'm going to find f of 3. So I'll just do a simple two-step equation. Subtract the 6 on both sides. You'll get a negative f of 3 equals 10 minus 6, which is a 4. And then, of course, you don't want the negative, so a positive f of 3 equals a negative 4. Okay, example 5. For example 5, it says the area of each region is given by f of a to b f of x. So here we have several different regions we want to find. And we want to find the entire region from A to B, and notice there's C and D in between. So then what I want to do is I want to find the integral of A to B f of x dx. is going to be the integral of the first chunk here is from a to c. So a to c f of x dx, plus the second piece is from c to d f of x dx, plus the fourth one or third one from d to b, which is f of x dx. I'm going to go ahead and replace the area. So then I have 10 for the first piece. Here it's below the x-axis, so it's going to be a negative, -2 plus 3. So then altogether, 10 plus 1 is going to give you 11 unit squared. All right, you guys, that is pretty much the breakdown of your notes. So then what I would like you guys to do for the remaining part of class is go ahead and read the guided notes here. And once you're completed with that, you can go ahead and practice with some of the questions in the textbook, finish your Math Excel, and also your AP College Board assessment. All right, I hope you guys have a wonderful week. As always, stay safe and healthy and take care.